Good evening to everybody. Welcome to the 8th session titled Virtual and Augmented Reality in the PDP program jointly organized by BMS School of Architecture and the Indian Institute of Architects Karnataka Chapter. The speaker for today is Rakshith V, and he has professional experience with virtual and augmented reality. He is from the Kyotek Pvt. Ltd. He's worked with the Bangalore International Airport Limited, especially with two main projects, with the T2 project and the visual walkthrough content creation. He has also worked in the Tumkur and Shivamogga Smart City digital planning. Along with that, he has been closely associated with the Karnataka Urban Infrastructure Development and Finance Corporation, KUIDFC. Rakshith V, thank you so much for accepting our invitation and joining us. If you could kindly turn on your video and take over the session for today. Thank you so much.
Yeah, sure. Myself, Rakshith. So thanks for giving the opportunity from the BMS School of Architecture. So I'm going to show the here we are particularly for the architect. Okay, this is about the content about the Kyotek and introduction to VR here. VR for the built and VR for the unbuilt in the same way. So we can talk about the AR for the built and AR for the unbuilt. And also we'll talk about the future trend and future technologies which is coming out with AR VR content. So I will briefly explain about the Kyotek. Kyotek is basically started in 2016 and it's a completely digital transformation technology and based out of Bangalore. And our vision is to solve the problem which is not solved by the traditional methods. So you can digitally, so we can solve those problems. So that is a vision we are with Kyotek. So these are our clients. So we are working with the BL Kempegowda International Airport, and we are working with the realtors of Shobha, Godrej, and Birla Properties, and we have the hospitality. We are working with the Kohli, Total Environment, 5 group of hotels, no hotels, and we are also working with the government of Karnataka with the KUDFC. So it's really the completely smart city funded organization. So and so we are also working with some of the mechanical industry called Warner Finlay. We are working with the Zeta India, BMD missionaries also. So we will come to the actual presentation of VR AR. So what VR and what AR? So the basic concept of what AR and what VR. So AR is basically creating a digital content to interact with the physical world. So we have for example, we have some sort of digital content that has to be showcased in the physical world. So for example, if we have some for the architect field of view, so we can have some furniture there. So we want to place it somewhere in the inside the building or inside the either 30 by 40 area, or you can consider as a 250 square feet of area. So wherever you want to put it. So just create your model and then just bring back to your into the AR content devices. So we can see it whether it is fixed or not. So in the same way, the virtual reality. The virtual reality is very trendy today. So due to this COVID situation and all, so technology, it's create a virtual environment is completely disconnecting with the physical environment. Like so, you are somewhere in the, for example, you are in the college, you are in the office or somewhere. So if you wear the VR gear, it is completely disconnecting your environment. So and it will create a virtual environment. It will showcase only particular in person, and then it will create an wonderful experience. So this can be used in many ways: architects, realtors, education, training, industries, and nowadays this is very common. Virtual reality is very common, and the augmented reality is also coming with day by day. So we can go with a brief about the virtual reality. So it's a digital content creation with a three-dimensional space. Exactly with the three-dimensional space, we can view the X, Y, Z, and we can normally we will use the head-mounted devices for the VR, and we have a different types also. So normally it can be seen up to 3 dimensions. So every angles, every position we can see up. So this is virtual reality for the architecture mainly. So for the built VR and unbuilt VR. So we are talking about the built VR and unbuilt VR. So built VR is basically which is already built one. Okay. So unbuilt is it is not built one. It is only have a 2D plan. So I will create as a 3D model kind of thing. So the unbuilt property, which is a creative model, and so which is a built property, is a physically existing model. So we can create a virtual reality for the both the things. So we are for the unbuilt property, we have a workflow for that. So architecture have a different stages like pitching stage, design stage, construction stage, and delivery stage. This is for the unbuilt property. For the architects, there are different stages are there. So in the pitching stage, what will happen? So we have to meet the clients, we have to meet the end clients. We have to give the presentation. So rather than showing a normal videos and photos, we can showcase the VR content which you have done previously works, and this will give them more concentration to the clients. So they never divert. So if you wear the VR gear, they never divert. Whatever which is comes in the VR gear, they will see it. This is most good thing in the VR. And so anyway we can showcase in our portfolio in the websites, or we can put it on our any social medias, and then so during the presentation also we can show it our in the tab or a laptop, that kind of thing. So we can show it, and using a updated technology in our, so this will, for example, if you showcase this type of technology to your end clients, they will feel that so this is a very good thing. So they have our our worker or our architect was at next level, so he's also adjust with a new technology. They will understand in a way. So next is the design stage. So once it is the pitching stage is over, so in the design stage, how it will work the virtual reality. So for giving you different concepts, normally we will give a 2D rendered images, that kind of we will give you. So rather than giving a 2D rendered images, we'll give you a 3D 360-degree images which we can showcase in the VR case. In the same way, so the better execution. So this will also helps us to better execution with the actual work. Okay. So and also we can understand the what is the challenges and during the execution, and what is the challenges to be for the execution team. Everything will be very clear, and also we can show the different designs concepts, and we can showcase them. This is the reality going to happen for the next 1 year or next 6 months. So this is the exact plan. We can tell about the, we can explain about one by one. The same way, the objective is very clear. So by showcasing this, the objective will be very clear. So this will give a clear objective. So and the client also get understand what exactly we want to going to be executed everything. So both the person, one is from the client end and one is the execution team, both can understand what we are going to execute finally. Okay. So how it will works in the construction stage with the architects. So this is the question will arise. So this easily track the construction progress also by we have already have a planned model, virtual reality model. You can actually compare with the construction progress on what date, for example. So I can compare with the 1 month, what is the progress of the construction. So in the next another 2 months, what is the progress. So I can compare what are the areas to be progress, and it will be documented also. So that is the one good thing for the construction stage. And it's very easy to execute for the interiors, MEP lines, engineers, and then floor tiles. So we can anyone can easily understand by visualizing the complete immersive walkthrough of the complete building, or a complete some complete virtual walkthrough. So and this way also we are, so we can also the BIM model which will be there. So we can also convert into BIM model into VR, and we can also see the how is the compatibility will be there, and how it should be, so we can visible, and how it will be there. So both can be, so we can see it, and how compatibly with existing with the BIM model we can see it. So this is the one beautiful thing in the virtual reality is the unbuilt property, and it's in the construction stage, particularly in the construction stage. In the delivery stage, so finally once it is everything is happened, everything is very clear, and it is all executed. So we can compare with the as designed versus as executed. So and also finally, so client we can show to the client this is what we are committed and this is what we are executed. We can showcase in a very good manner, and it is very easy to close the project. So rather than any question, not any other questions will be raised like you are not done this, you are not done that. So not even that not question will be raised. So it will be smooth closing the project in a good manner. So in the same way, so it's a, for example, the client asks for the any other extra works also. So we can easily tell them like this is what we have committed and what we have executed, and do you have any other works also? So you have to pay extra for that and get it done from us. So this is what we can tell them in a very clearly manner. So this is for the unbuilt. Completely, this is for the unbuilt for the architect. These are the different stages will be there. Pitching stage, and then next one is the design stage, next one is the construction stage, and this is the delivery stage. These are the four stages will be there. So this is virtual reality for the built workflow. So that is completely virtual reality for the unbuilt, completely with the computer integrated graphics. Like it's a completely 3D model creation and creating a 3D model and rendering, and then we can create a immersive walkthrough inside, so we can see it every corner and we can see it. I will show you the one of the example which you have done for the virtual reality unbuilt property. This is the completely 3D model. This is computer generated model. This is for the unbuilt model. Okay, so I can showcase to clients before starting their construction. I can show it what exactly the T unit will become, what marbles I can put. Okay, so how it will be look, everything we can showcase. And also I can showcase the multiple texture change also. So I can click on this. I can check. I can click it on multiple options. I can change it instantly. In the same way, I can show. I can change the colors of the font. Also, I can change the textures here. So by seeing this, the customer, the client will, the end client will be, they can decide what they want exactly. So they can decide in a one meeting itself. There is no need of multiple visits or meetings. So they can decide. We can give a multiple options to them. So they can decide there itself. So and they can conclude what exactly they want the design. So I want a balcony option. So our balcony is there. I want to go balcony. Just click on the balcony. So it will take to the balcony. So I can see also I can also visible the or we can be seen from the balcony also. So here I can you can see the AC duct also. So I can AC duct also place is there, and everything was in detail captured and in detail we have modeled and we have delivered to client. So next time also I want to see the toilet also inside this bathroom. So you can see the wardrobes area I can see the complete environment, how it will finally. And window will be there. Everything will be very clearly mentioned, and we can this by seeing this, client will be very happy. Like so, this is what the final executed one. So if any changes also, by seeing this, they will uh, tell us like what are the changes needed, why which areas changes needed, so they can. So normally architect will do the single rendering images rather than doing that one. So better to go with this technology. So showcasing VR, so they feel very comfortable, and then they can see it what exactly our room looks, our balcony looks, or our toilet looks, what exactly our living hall, kitchen. So for the industries also, in the same way we can do for the industries also. So multiple things we can do it from the unbuilt. So it's a completely digital content from the 2D to 3D plan. Okay, again, I will go back to my presentation. This is VR for the built workflow. So, here creation of a content for the build and unbuild is completely different. So because that is a physical model, for the built model is there. So for the unbuilt, there is no physical model. We have to create from 2D to 3D, and whatever the concept from the client, so we have to do it. So these are the so we for the creating of a VR build model. So we need some external cameras and laser scanners, and then devices we want. So this is workflow how it will work. These are the different cameras, Matterport, Para, Leica is there, and so we are planning set of data we needs to be captured. So we'll capture the data, and after that we will register it. This is a complete process will be there. So after registering of this, we'll generate a cloud points or a 3D surfaces on that. So after that, it will we can take to the civil 3D recap, or we can go to the Revit also, and from there we can generate a surfaces, and we can create a surface on the create. We can model it, and we can decide what we want exactly. So we can go for it. So in the build also we have a different workflow. So unbuilt have a different workflow, built have a different workflow. So in the there is no pitching or nothing will be there. So it will directly we can go to the design stage, and then construction stage, and handover stage, and facility management. Okay, so where exactly it will work for the facility management, it will work more. And for example, if you done for the MEP lines and all, after 1 year, 2 year, some leakages will be there. So they want to see it. So where exactly the problem is. So and where the pipe is gone. So it's easy to track with a virtual reality data. So rather than by seeing the 2D plan data. So this is a design stage how it can be captured. So this is this is the project we have done with a laser scanner. So we gone with a laser scanner, and we have captured the particular data. So it should be shown in here. So this is the complete capture data. So it will also create a cloud point, and also it's generate a surface model with the civil 3D, and that also it can incorporate with the recap, and after that we can take into the Revit. So so it will eliminate your manual measurement and multiple visits to the site. So once it is captured everything, there is no need of visit for the exact site. So you can measure it here itself. You can see the orientation, and you can see the uh, upper level, lower levels also. We can see it. So this is the data captured with the multiple locations. This is the factory locations, and this is the company factory areas, and this is the open areas we have done it. And so not only with the scanners, and we also done with a drone also. So it's a drone mapping technology. I will explain you in the next few slides. So these are the different locations we have scanned it, and we have delivered to the end client. So this is the construction stage. Presently, it is going on with BALT2. So this is what we have with Matterport scanners, and then this is with the laser scanners, and this is also with the Matterport, and this is also with the Matterport. The multi-level also. For example, if it is up to for the Matterport, it will take up to 15 feet. So and laser scanners will go up to 100 meters. So there is a lot of difference by using of this, where exactly we have to use, when to use, how to use, and what the customer expectation at the each stage. So we have to understand, we have to deliver the things stage by stage to the end client. So this is not only for the BAL, and also this is implemented on your individual houses also, and any industries also. So we can also big. So we can also done with Tumkur Smart City, which is one of the library was construction going on. So we can stage by stage, month by month, we will give a recorded virtual walkthrough, visual walkthroughs. They can understand what is the progress of this month and previous month, and they have a complete track of that. So and this will also help to the contractor to get a payment also. They can get the approval from the authority of Tumkur Smart City, and also these things are also sent to be KUDFC. So for the final approval, and this is the way it will go. So this is also created document for the stage by stage. So one of the interesting thing in the BAL was, so they want to compare with the as built and then as designed. Okay, so this is the CAD model is as designed, so which is you can visible on the left hand side. So after this, so the end client, so our client will tell us to go and scan the particular area. So after the construction of the particular pillar, okay, so we will go with the scanners, and we have scanned it entire thing. So you can see that this is the real area, we have captured it, and we have overlapped it in the Revit. So it's an so it will create a normally it will laser scan will create a cloud points, and based on the cloud points creation and model creation, we will it's a complete process will be there. I will explain in the next words how it will be registered and everything. Okay, so and then this will be compared with the CAD model, and we can easily get to know about how the deviation, what the deviation will be there from the column to column. Okay, what is the 1 mm difference also we can get to know. The accuracy of the laser scanners will be plus or minus 1 mm. So we can easily identify what is the deviation from the column to column, from the as designed to as built. In the same way, beams also we can do it, walls also we can do it. So entire project we can do it stage by stage, and we can showcase to the BIL client. So Bangalore International client. So next is the delivery stage, and also it will also helps in the creation of MEP lines also. So this is the MEP line. This is the AC duct which is going on, and if it is any defect also, we can identify, and we can my sub vendors. So we can show to the sub vendors like this is what we have rectified some of the faults in the site, and this is also helps us to identify what are the faults, how it will be the executed, and the plan one will be, if it is correct or not. So both can be compared with a visual concept. So this is the delivery stage, and also we can cross check with the all the things in the during the delivery stage, and we can see it from office itself. Though there is no need of multiple visits also for the particular sites and all. For example, site is away from 100 kilometers or 200 kilometers. So one scanner guy is enough. Once he is gone to the place and he scan it once, everything will be captured and everything will be visualized. I will show you the some of one of the example. Okay, this is the construction site. So we have captured it. Okay, all MEP lines will be visible here. So I can create a tag there, what exactly I want to say. So this is one example. So we can mark it and we can say it what exactly we want. So this can be visible in two manners. So this can also be seen in on our mobiles also, and also we can any electronic gadgets like these things of only browser, and this is compatible with any VR case also, this link, and this is directly compatible with the VR. So we can go with Oculus Quest and Google. Minimum from Google Guardboard to STC Viva, we can go for that. And from the advantage of this, not only for the visualization, so I can see the floor plans also. Okay, so I can get a complete dollars view of this. So I want to see it what exactly, so where I want to go. Just one click to, it will take to the particular. So I can see the what is the progress of in this area. So I can mention what exactly this is. So like this, the entire project we can walk through it. So entire section, every step we can walk it. So once it is done, so there is no need of there is no need of visits. We can measure also. We can see what is the progress. We can measure the columns and beams also. Every angle, every position we can see it. So this is the one advantage. So I will go back to my presentation. Okay. So after once it is sealed up or once it is covered up, so for the facility management, people easy to understand where exactly the, for example, when the leakage is come, so where the pipe gone inside the wall, so they can see it, and if there is any misconnection in the electric line, so they can see it the where exactly the we can measure in the virtual model what is the distance from floor to that particular area. So where exactly the pipe is going. So everything will get to know. So this will help us to facility management in the for the big projects, also for the small nowadays the small projects also they are going without this documentation rather than only they're taking with the 2D drawings. So this is how the data compatibility will be there for the virtual reality. Okay, so one is the visualization part in the virtual reality for the built properties, and next one is so we can take to the recap, civil 3D in Avis work, and then Revit also. So we can split up, we can create a 3D surfaces, we can measure it, and also this can be compared with the BIM models. So how it will be, our BIM model is going safe or not, and also what the progress of the project, and also we can identify. We have a cloud compare option also. We can compare with the what is the progress and what is the design, everything by month by month. So we can stage by stage we can make a documentation for it. This is the complete integration. This is the Revit we have done it. So complete integration of the BAL office, and this is a cut section. We have done it in as a recap, and this is on a recap project. So we come to the details. So we are for the build properties in a different manner. There are three varieties of this. One is photogrammetry by drones and DSLRs. One is by laser scanning, and another one is by 360-degree cameras. Okay. So there are three types. Why are going with this? We are this type of detail, and this type of details. Why I'm going to say is these are the main things which will build the VR content for our construction products or finished projects, and this will help us to get to know what are the capability of the individual and what the technology they are using. So DSLR, and this is a normal camera, and we can take up in the mobile cameras also. And this is a drone in the same way, so it's only taking the photos, and also will take some videos also. So it will principle is based on a triangulation basis, and it is a multiple photos. We can't do with a single image. We need a minimum 2 images to get a photogrammetry. So technology, it's already predefined softwares out there, so there is no need to start from the scratch also. So just we have to take the photos, and we have to particular areas how the density of the photos will be there, like the overlapping of the photos, like 75% we are overlapping with one another, 65%, 70%. So depending upon that, the quality will be improved, and also it is also depends upon the your gadgets, like how the DSLR quality is good, how the DSLR will be there, and what is the drone specification. If it is a good drone, it will comes very beautifully, the cloud points and all. So it's depend upon the those things. And also very important is line of sight and the field of view, FOV. So field of view, what has to be put it, how much has to be put it in the drones and all. So these are mainly line of sight, and then very important in the drones, and the field of view also very important in the drones. When we are capturing the very capturing the where the human where the human cannot go and then take it. For example, DSLR in the forest area, they can forest area can in the cities you can the cities we can take an example of lakes. So in the DSLR, if I to take the complete lake photos, for example, it is around 300 acres, 200 acres. It is very time consuming. So by using of the drones, I can take for the 200 acres of land. I can take by another by 4 hours. I can finish it off. Entire photos I can take it. After that, I have to take to the particular software, and I have to process it, and I will create a cloud points. It will also create a 3D model. So the accuracy will be also very nice, and it will be also not more than plus or minus 3 mm will be there. So it will be very good accuracy. We can compare with so we have done with the Tumkur smart city project for the road verification with design versus as built. Okay, so that will also I can showcase in one video. So this is the technology. So this is the one simple concept I am explaining about the photogrammetry. This is the aerial view which is taking the top. So this is by drone. Okay, this is the cameras are is a terrestrial and handheld, and we can use by a tripod also. So this is completely as a photogrammetry model. So it is created by point clouds and created a surfaces, and it is completely of a 3D model. Okay, we can rotate it and we can see it. But the compatibility and the size of the model, if it is varies, it's very difficult to handle in the present day. So that's why it's a limitation in the overlap also. If the more overlap will be there, so I can get a more data. So if a less overlap is there, I will get a less data. So these are also mesh count is there. So I will explain in the next slide also that mesh count, how it will be works and all. This is the photogrammetry. So how it will work, it's a triangulation method. So we are taking about 3 photos, 1, 2, 3 photos. So and it will take the overlapping by 65%, 75%, whatever we will give. So based on that, we will going to mesh, and finally it will create a 3D point cloud data. And after that, it will create a mesh data. Mesh is a triangulation mesh it will generate. So how dense it will be, the mesh will be there, and that will reflect your storage data. For example, the mesh data will be very less. The mesh data will be very normal. So it will be normally it will goes up to 2 GB, 3 GB rapid data. So if it is mesh data is very high, so it will goes up to 10 GB, that kind of data. After creation of meshing and everything, it automatically in a photogrammetry, it automatically detects the surfaces and it will texture as per the exact data. So what is the benefits of this photogrammetry? So photogrammetry is very affordable rather than going with a 360-degree cameras and then laser scanners. Those cameras is very expensive and the softwares are very expensive. The photogrammetry is benefits more in the initial stages. If you're going for the completely high-end accuracy, high-end professionals, so we can go with the laser scanners and the 360-degree cameras. So this will photogrammetry benefits in a non-contacting one and very fast, high accuracy, good point accuracy, and noise level also is not that much high. So it will also go up to medium and very not that much large object. So we can go with a very similar kind of thing like 30 by 60 areas, and also with the DSLR. And with the by drones, we can go up to 200 acres, 300 acres, and we can capture the hill areas, lake depth, everything will be, we can capture it. And so I will show you the one of the video which I have done for the one of the lake. So So this is the one of the lakes we have captured, and we are taken into the augmented reality. One second. So we have doing with this with a tab, and this is we have captured by drones the complete lake with a depth, and you can see the water also, small water content will be there, and you can see the land beside the lake and trees around the lakes. We can see it. So the depth and then soil layers and all, you can easily visible. So this is a recorded video, so we can if you go with an exact software, so we can see it in detail, and also we can measure it, what exactly the distance, what is the depth, everything will get to know. This is what the exact 3D model will become. So in the same way, so we have done for the road also. So it's a road construction with a railway intersection will be there. So here need to find the surface. Okay, this is the completely road stretch. And we can see the beside of land and plants also is there. So complete, it will fit on any surfaces, anywhere office or any outside areas also. We can see it and we can zoom it. We can visualize what exactly the road surface, what exactly the road interface from. This is the railway junction. Okay, so it will pass us like this. This construction, the bridges construction is going on. So actually, this is done by drone photogrammetry, and after that, it will take to the augmented reality software. Now we are exactly you're seeing with augmented reality. So we are showcasing the, like you can see the water, water storage also. So complete landscape will come into picture, and by using of this photogrammetry, so we can count the number of plants also. We can count the number of plants and what is the area, and so everything will get to know by this photogrammetry benefits. And this also used for the counting in the forestry. Forestry area, how much area will be there, and what is the dense forest, where exactly the dense forest is there, and where exactly the plants are very less. So that will help them to understand where exactly we have to plant the future plants and small plants also. So that is one for the virtual reality content by the DSLR and then drone. So next thing we will come up with the laser scanner. So this is the way the laser scanner is very good scanners, and then this will be very accurate scanners in the world, and this will give a more accurate data, and it will goes up to 1 kilometer also. So 1 kilometer will not be using for the architectural. It will goes in the uh, army, or they will use in the novel basis. They can identify the thermal mapping, how where exactly the ship will be there, where exactly the activities will be there in the armies and all. So normally it goes up to the 350 meters for the architecture scanners. So this will capture the, you can see the, so it will capture the bridge and the buildings and the entire stretch, you can see it. So it's a leader is a light detection and then ranging, and it will not affect any human beings. It is a first class cameras, and it is very clear, and its accuracy will be less than plus or minus 1 mm, and so the accuracy difference will be less than plus or minus 1 mm will be there, and very accurate. And we are using the laser scanners for the BLT2 also. So visualization purpose, we are using a 360 camera. The same parallelly, we are using the complete capturing the data in a very accurate manner using the laser scanners. So there is a small difference in the laser scanners, and there are different types also. So there are two types of laser scanner will be there, and there are two competitors also will be there. One is Sparrow, and then one is Leica also. There are the most well good efficient laser scanners in the world, and they will use this kind of technology, time of flight and the phase shift. Okay, time of flight is normally how it will. Why I'm telling all those things, so you can also understand which will go better and which will technology which will be the best technology we can go for the projects and all. So in a phase time flight of scanners, it will be hitting on the laser scans, hitting on the one surface, and come back to the again with a laser scanning device. So what is the time taken? Based on that, it will calculate the distance. So and that also based on that, so it will create a particular point, and from the distance from the laser scanners, it will create a float point. So in the same way, so phase shift scanners will be there. So the same concept will be same, but it will take the phase shift by phase shift wise calculations, and it will also distance the same in the same way. After that, it will calculate the distance. So phase shift is only normally it will using not more than 500 meters. Okay. So time of flight will be used for the ranging from 1 kilometer to 6 kilometers laser scanners. So this is the 360 cameras. We can go with and capture, not only creating a video, so it will also capture the 360 virtual tour integration nowadays. So creating a virtual tour for the model apartment in the villas. So we can go with an Insta, or also we can go with a Matterport. You can go with a Theta also. So a number of cameras will be available in the market. The best cameras will be Matterport in the present today, and also we can go with an. We can also done with these DSLR images for the visualization with the DSLR also. So we can take the multiple images and we have to stitch it together. These are the cameras will come up with a build, so they can stitch automatically and they'll create a 360-degree views. So I will show you one of the example which you have done with a 360-degree camera and the completed project. Okay, so this is the project, completed project. So this is creating a virtual reality. What I've showed in the construction stage, the same building I have done the virtual tour after finishing. So the previous one, what you showed, the completely concrete one. This is the final finished product. Before giving to the end client, before given to the handover to the end client, they will create a these kind of virtual walkthroughs. So this is for the this is for to identify the any mistakes in the complete area, and also it will create a documentary for them, and also they will make it as a portfolio. One of the portfolio they will make it this kind of office spaces, and for the end client by send this link, they can visualize from there itself. For example, he's sitting somewhere in the abroad, so he will send to link to them, so they will see it from there itself, and they can visualize and they can confirm the what the work done, and if any clarification and any mistakes and any suggestions to be needed, from there itself they will do it, and there is no need of physical visits from there. So one a single meeting they will finish everything. So after that, so it will also for the rented spaces, It will also give us a documentary. What are the damages happened when they are there, when they are revealing from the particular place. So we can compare with this and that. So what is the damage I've done? What is the replacement I've done? So everything will come to the conclusion, and easy to convey it for the both the end client and the present client. So both can understand easily, and very clear picture it will give. So normally here in the previous days they will take the n number of photos and videos for the visualization purposes to send to anybody. So photos, what will happen? So there is a if we take the photos in a one single angle, so they can't understand what exactly they are going to do, what exactly they are seeing it. So for example, I will take one simple this angle. So what behind this area, they can't see it in the single image. So, but the virtual walkthrough, it will give a clear picture. And also, if I go with the video, what the way the cameraman shoot, so only that angle we can visualize. So rest of the things we can't visualize in a proper manner. So it's not possible also. So it will eliminate those problems. So by taking the n number of pictures and taking the unnecessary video, so it will gives a clear picture in a single virtual walkthrough, and it will create a complete documentary, visualization, everything. So in a single link, they can do the multiple tasks. So again, I will go back to my presentation. So this is the Insta 360. This is integrated, and this is the Matterport. We are both we are using it, and we have multiple cameras with the laser scanners, and we have done with the DSLR also. We have checked it. The what is the procedure normally? What is the procedure and how it will be fast? This is faster than laser scanning, and then this is faster than laser scanning and then drone capturing also. This is very easy to set up camera, capture data, and easily upload and download the data to your local devices and upload it on the cloud. And we can process our data by manually, or we have a cloud software also. We can upload to cloud software. It will process automatically. And after processing it, we have to post process it. Like what is the tags we have to put, what is the name we have to put, and we can get a final link that can be shared to anybody anywhere in the world. And this is also we can be open in any devices. This is compatible with any mobile devices, tabs. So it's need of only browser and internet. So very compatible with nowadays. So one more example I want to going to show for the this kind of VR for the built properties. So we can create a, for example, we can go with a very old buildings which we have done in the Shumaga Smart City. I will show you. This is the old British building. They were constructed in 18. So for this building, they want to uh, changing. They want to alternating some interior designs, and they are alternating some around the concept. So they want measurements. They want a floor plan also. For example, for the old buildings, we don't have a floor plans at all. So by capturing of these, I can go. I can visually see the how exactly the location, how the steps, what is the distance. So I have a measure tool also. So I have a measure tool also. So I can measure from here itself. So what is the distance between the wall to wall? I can see it. So what is the distance between floor this time to this time? So we can visualize it. We go inside. We can from this capture data we can create a 2D layout with AutoCAD. How the ceiling will be there, how the ceiling design. So every design we have a floor plans here. So you can see the floor plan. So we can measure it from here also. What is this thing to that thing? You can measure it. So I can create a floor plan. So any measurement can be taken. So and also I can visualize the $3 to how it will be looks as a 3D model. So that also I can from this I can take a cloud points also I can create a surface model, and once again I will create a 3D model exactly for the unbuilt walkthroughs. So exterior area, what is the distance between from building to the particular park area. So we can visualize our exterior, interior, both can visualize what exactly this is, how it is becoming, everything. So this is the most advantageous to for the old buildings. We don't have a floor plans, and it is demolished or it is by any natural disaster, earthquake or something. So uh, if it is loss, also we can again we can um, start doing from the this type of links, and we can create a 2D plan and 3D. We can create back to 3D floor plan. We can construct once again as it is. This is the one good advantage, very good advantage of the archaeological department. So this is the creative creation. Mainly, this objective is to create a documentary for them, the Smart City Corporation of Shimoga. So that's why I've showed, and this is exactly the VR gear with a structural sensor. Okay, so we'll talk about the varieties of VR gears in the market, and in the next few slides. And this is what we are showing here is this is the VR gear with a structural sensor. It will give a depth also. So what is the, for example, it will give a 1:1 scale. So how many steps you will put in the real physical life also? If you put a 2 steps, the same manner, the same concept, it will showcase as it is. So this is the one structural sensor, very useful for the VR also. It will also useful for the air content also. So it will also the main reason using the structural sensor for the giving the depth of the field, and it will identify the what exactly where will be there by taking the coordinates. Okay, types of VR gears. So normally we have three varieties of VR gears in the world. One is mobile operated devices. Okay, another one is the standalone devices, and is the PC connected devices. So VR headset is mainly it's only for the head mounted devices. So virtual reality we can experience only if I wear the VR gear, but also we can see it in our desktop mobile also. But if you want to completely look into the particular environment, you can you can shift to the you can disconnect to the present environment to the digital content, you have to wear the VR case and you can see it. So now for the very affordable price, we can go with a mobile VR case with a Samsung VR case with a S series. And in the other devices also will be there, very less cost, around 1000, 2000. That is compatible with very normal any mobile phones, with any Android mobile phone. But it's not much that much clarity and then that much experience will not give. This second one is standalone devices. It will work as Android devices in the same way. So it have a RAM, processor, and everything will be inbuilt. And we have the browser, and we have to connect with the Wi-Fi. So browser also will be there. If you have a links or if you have any content will be there, we can easily see it by through VR gear. So, so we can see it very clearly. So the next one is the PC connected devices. So it is a wire connected. It is more accurate one, and graphics are very high. So and this is costlier also. So standard devices is very comfortable for the mid-stage users, and it is also comfortable for the training, education, and all. PC connected devices is the next level. It is more accurate and then more comfortable and very clear visualization will be there. So after seeing of these, all these we are for the built and unbuilt. So we have a limitations for this. Some of the limitations will be there. One is the data limitation. If it is more data, it will open very slowly, and sometimes it will crashes. That also will be there. And graphical data for the lightweight, which is hosted in the cloud, that will open easily. Any review data, it will very difficult to open in your mobiles and all. So it is not compatible with your mobile phone. So we have to go with light, Revit light, those kind of software. Or we have to go with a direct with a desktop or a laptop devices. So and now and also facing the some devices which is head-mounted devices are heavy weight present day, and these are not, we can't bear more than an half an hour, 15 minutes like this. So it will be we are not adjusting to that environment also. So sometimes so it will remove your virtual environment automatically. So it will appear sometimes. So it is giving a complete locomotion sickness, that kind of things it will. And compatible devices is very less now. Like, but this is compatible with all the devices, but the experience and all not compatible with all the devices in a present day. So in the future days, it is coming with AR, VR mobiles. So that will help us to use the AR, VR content anywhere on the any, not only for the architect field or realtor field, we can use in the many fields also. This is the one good advantage which is coming up in the next years. Okay. So here for so we'll talk about the completely of VR content. So that is our vast content and with this, that is of particular projects and a number of projects we have done it, and then VR is more affordable also. And then for the VR content creation of 360-degree videos, not for the laser scanners. Laser scanners, something somewhat some professionals they will go for that. Like it will cost more than the 360-degree camera. So this AR is nowadays is coming with a. You can see the ARS lens chart in the websites also. So in the same way, so we are doing with the in the architect field, we can do the furniture styles. So and also we can doing with set of fans, set of kitchen equipment, so MEP lines. So all things. This is one of the example. So they have created already created a chair model. So they have taken into the phone. Okay, so they have taken into the small mesh, like very less mesh kind of thing. So this will I can go and wrap anywhere in a particular area. So it will background it will showing the physical audio. So what I've showed the lake view, and then what I've showed the road view, the same way. So they are doing it in a inside the house. So they can place it and they can see it what exactly, where exactly they can see it and how it will be look beautiful. So they can decide and they can conclude so whether we are going to buy or we can change it. So like this, we can use the multiple models, not only the single model. We can use the multiple 15, 20 models, 30 models. We can use it, just swap and we can see it and how it will be looks beautiful. Okay, the workflow will be in the year for the unbuilt. It's for the architects will be there. Normally, only the 2D will be there. So we have to create a 3D rendered model and rendered model with assets, and we have to complete environment. We have to create it, and we have to upload those models to AR devices. Otherwise, we'll upload to the any cloud accounts, and then the same link we can use it in any VRD AR devices. Okay, so once it is uploaded or once it is processed, the model, so we can easily easily taken into the any devices, and we can showcase it. And this only for the not only for the architectural field, we can missionaries also we can see it how it will fit, and also for the entire 30 by 40 building, elevation building, I can make it in a 3D model, and I will go to the site, exact site, the complete empty site. I can place it in the empty site. I can see how it will look in the exact site also. We can do it for this architectural field. So that level we can see it, and also we can place it, and we can walk around the complete building. We can walk around 360 building. The building will be stable. So the 3D content building will be stable. We have to hold the tab or a mobile. We have to walk around the complete area. So this is the air content for the architect we can create it. So example I have showed for the air content. I have done it for the lake one, and then the same way we can do with the modeled one also. So the same way I can done with the road also, the same air content for the unbuilt structure. So here content for the build structure, it will be works in the similar way. Nothing will be difference will be there. So only we are for the unbuilt, we are creating a 3D model. It's a graphical model. But in the build model, we are creating we are already created, we are already captured the laser scan data or a 360-degree data. We can take it into the AR content. So this is the only difference will be there. And this benefits this benefits in the architecture field is nowadays it's very going nice. So for showcasing 2D plans to 3D plans, for example, you can visit to the any we have done for the some of the Prestige and then Showband and Godrej also. So they have a brochures, they have a 2D plan will be there. So they have some tabs or mobiles with a salesperson in the sales office. So just follow the floor plan with the mobile. So it will automatically showcase the 3D model on the brochure. So they can also change the colors itself, wall colors, and they can see it and what is the difference, and they can visualize how the 2D to 3D in an instant manner. So it will minimizes your time to visit the model apartment, and also no need to again go with the 3D rendered half-cut floor plans and all. So in a one shot here benefits. So by showing you 2D plans, so it will create a 3D model, and it will create a 3D floor plans also. And it also showcase anywhere in the world, anywhere, anytime. So there is no limitations at all. No need to only the single environment. It will not limit it to single environment. You can showcase to anywhere, anytime. And the same way we can visualize the total project also. We can visualize and total project, and also it will be benefit for the by using the coordinates. Uh, we uh, we have done with the BACL in the Bangalore International Airport itself. So there is a empty land is there. So they are going to construct the shops there. Okay, so they are going to construct a shop. So that shops to be visualized how it will look in a 3D content. So we have done a 3D model, and with the help of the coordinates, if you go to the particular place, it will showcase the 3D model one by one. So for so it will showcase the building 1, building 2, building 3. So if you walk through the entire empty area, it will shows the MEP lines also. We already designed, and we already modeled, and we already created a air content. So by seeing this itself, so they can identify what exactly, where exactly, what it is coming, what it is there, and they can also visualize without constructing anything also. This is more beneficiary things in the air content. So air devices nowadays, it's a head mounted devices. So holographic displays and smart glasses will be there, and handheld will be there. So nowadays, most of the people are using handheld because it's a very affordable price we can get it, and head-mounted devices are very costly nowadays. The present is very costly. In the future, we can expect some of the affordable for the common people also. So this is head-mounted devices. The second one is which I've showed. So it will creating a 2D layout to the 3D model. So we can visualize where exactly what is the elevation, what is the space, everything will get to know. And we can measure also in that, we can see, we can rotate it, we can see it, and it's completely interactive model. So Microsoft HoloLens will be there for a year devices. This is most costly year devices nowadays. Magic Leap one more, and Google Glass and devices. This is all connected to the computer integrated devices. So there are completely integrated or Wi-Fi connected devices from the computer. This is the limitation will be there for the air also. So here the main limitation, the big limitation will be the data management, mesh size. So we have to model the furnitures for the architects or somewhat building how to model it. It will goes up to 3 GB, 4 GB, 5 GB depending upon the size of the building. So the whole 4 GB I have to come to, I have to taken into the mobile devices. It's very vast data. So what I will do is a mesh size will be there. So mesh is a kind of creation of surfaces with multiple points. So that has to be reduced by different methods. One is by capturing the data, capturing the modeling of the particular product. So it will be different from one to one. And after that, doing of the model also, we can mesh size we can vary. So there is no need of taking the complete solid model. We can only create a surface model of this. For example, I want to create a model of the building, okay, with the multiple floors. I will only model it only the surfaces, not inside walls, nothing. Only I will make it only the surface of this model, and also that model I will keep it as a less mesh model. So, and it will be not more data when it will comes to the mobile data or a tab data into the tab data software or mobile data software. Okay, and it is this air content creation of air content and devices is nowadays costly present word, and that is one of the limitation by not using it popularly. Only the handheld devices are very affordable one. Nowadays, many people in the realtors are using it already. And graphical limits, it's the graphical limits also depends upon our mesh size and data management also. If I give the eye render also, so it will take some more data. and that graphical data is also not compatible with our devices. So not much more data is not compatible, but small buildings and then small areas, small furnitures or small kind of architectural products we can use it. So weight of the devices, which have showed the devices, they were also weighted only. Not much comfortable to use. Presently, the addiction is not come in present days. The addiction will be not yet addicted the people, not yet addicted the people for this air content devices, and the compatibility is very less. Not for the all mobile devices. Okay, in the future, so all come up with AR VR devices, and one of the good thing is so Apple is come up with a lidar based lidar based devices with a 12 I think 12 Pro. Okay, so that is compatible with very VR and AR content. That is very suitable. We can see the VR AR content, and then we can use it properly. And also that laser scanners, that lidar based 12 what I have told Apple 12 Pro. So it will also create a meshes also. So you can if you have any 12 Pro also is there, you can scan it and you can create a surfaces, small surfaces we can create it like a mouse, or we can monitors, laptop. So we can create it and we can see how the textures and how the compatibility of the model, how it is creating the mesh and all, everything we will get to know very easily. Okay. So we have talked about all the VR and AR content. Okay, so almost from 1 hour. So so the final concept of VRAI is, one is the visualization. Okay. Next one is the progress of the project tracking. Okay. So the main objective of that. So we are going with the AR VR content. So the one is the immersive experience for number with the VR, and next one is the accurate build as design. So it's a completely of VR AR content is completely with complete package. It comes with our architectural construction stage, a design stage, or your planning for the execution, or your delivery stage, or the facility management. It will work for the all your stages. So it will also create a documentary construction stage. So it will give a very immersive experience for the visualization, and also it will eliminate your unlimited unnecessary visit to the site, and also you can visualize the how exactly in the AR content, how exactly the product will suit on the particular area. So that AR and VR gives a very good progress and very good knowledge to the architects and the clients also. For the end clients also very happy to understand how exactly it is going to become, how exactly the use is going to be used. Everything will come into picture. So what is the future? Is the future is the VR here is already is leader come with some of the smartphones nowadays. So in the future it will come with other AR VR phones also. So it will be very comfortable to use to anywhere in the world. And also this online, so nowadays we have done with one of the tile shop. So they can, if you go with a tile shop, so you can just enter into the devices. You can see the what is the tile size, what is the tile rate, and what is the variety of tiles in these, and everything will get to know. So I have the one of the example I have done. My client is I can't show the my client um, examples. So that is an India signed one. So this is one of the examples how they can use for the cloth shops and then furniture shops also. So like this, you can go and you can just hold a tab or a your mobile itself. So you can identify where exactly the where exactly the section will be there. For example, if you go to the any big malls and all, so you have to search for the where exactly the particular mobile shop is there, where the exact the cloth shop is there. Very difficult to identify. So the next trend of AR is you can just enter into with your mobile devices. It will show us where exactly go. Just you have to type the shop your shop name or what you want in the particular area. It will navigate to the particular area. From there itself you can track it. You can track it as a like a Google map, how it will takes to the particular place. So it will track with the AR content and easily identified. And you can also shopping by online. By shopping, there is no need to ask the multiple price and all. Just scan it and you can see it. No need of and also this COVID situation, though rather than putting a multiple lands there, so rather than going within these kind of structures, and then you can see it. And this is this VR content, you can see it in the um, in that particular environment. And the architects, for the architects, it will also helps to place your cards, place your commodes, place your wardrobes, place your windows, where exactly it will suit. And also varieties of curtains you can identify by going with a real environment. And also it will also help us to decide the tiles. You can also swipe it and you can change it. What is the tiles it will be suited for the particular building, particular area. So in the future it will go, and also it will minimizes your more time. So it will minimizes your time and then unnecessary things. So it will be there, and it is very good for the future. It will gives a very strength for all architects and then designers, and then so it will also gives a very good benefit to the clients also. End clients also it will benefit, and the entire world going to be changed like this. So it will be one very good thing for us to stay with the AR VR for the future. Okay, so this is my presentation ends. Okay.
Rakshit, thank you so much. That was very informative in terms of, making us understand how we can translate our vision to the clients and what is the kind of current work that is going on in this field, and the even the equipment that you kind of explained, because we are aware of
Your voice is not clear.
Oh, sorry. Am I audible now? Am I audible to you now?
Yeah, yes.
Right. So yeah, like I was saying, so you've given us quite a bit of information about the current equipment and the kind of work that is going on with your company and otherwise in AR/VR. But we have two questions for you from from the participants, and
Okay.
one of them is by Shrirupa ma'am. So if she could unmute herself and ask the question. Shrirupa ma'am. You can unmute yourself. Yeah.
I just got it. Yeah. Hello. Thank you for a good presentation. Very informative. I wanted to know, the first thing you had mentioned that you create a cloud point.
Yeah.
Now, how do you create? Through your software? Like you capture the images and then you put it into some software to create that? Or how is it? It might be a very basic question, but
yeah, it's a very basic question. So okay, so I will clarify, no problem. Okay, so in the photogrammetry, for the taking up the multiple photos, and it will create by the triangulation method, it will create a cloud point data. Okay, so it's a already we no need to create a cloud point data by manually. All a set of softwares are there. A number of softwares are there. We have to choose the good software, and we have to put the multiple photos, and we have to create the cloud points. That is the one thing.
Okay.
The second one is if you are going with the laser scanners. If you are going with the laser scanners, it will directly creates the their own software is there. For example, Leica, they're having a own software, and then Faro having their own software. Okay, the particular scanners having a particular software. they will create it instantly. So there we no need to do it manually. So we have to only capture the data, it automatically creates there itself. We can offload, we can directly download it in a offline.
Okay. Okay. See, I had another question.
Okay.
Can I ask, or someone else?
Yes, ma'am, please go ahead.
Okay. See, I saw that you were taking pictures during construction.
Okay.
Like, you know, what I saw was probably a fire sprinkler line or something that you were taking photograph. That was at probably a very early stage of the project. But as we progress with all services coming in and overlapping with each other,
okay,
at times there is no space to really access the camera.
correct.
Push the camera into that space. And also, I mean, any project will have numerous activities happening from architectural perspective to fenestration to MEP to interiors, everything. Now, if you have to capture the as-built versus what is designed, I mean, how do you do that? And to ensure that, you know, it is correct, like, you know, you must be overlapping it at a later point, right?
Correct.
Yeah, but the point is to ensure that we don't miss out on anything. I mean, how can you ensure that the as-built is exactly what it has been designed, or you have captured all the data?
Correct. For this particular problem, so we are going with the lidar scanners only, laser scanners only. Okay. So laser scanners, so it will takes up to it will takes up to 150 meters. It will takes up to 100 meters, whatever the distance will be there. Okay. But what is the advantage of this laser scanners is there is only that human how the like what is the space needed for the human food, that much is enough.
Okay. Okay.
That much is enough to stand my laser scanners to take the data. So because in the BAL, so everywhere you can see the around 20,000 people working day by day with the L&T. Okay, so and they have done with some of the supporting structures. They have put it some wastages. Everything will be there. Okay, so but we need to take care about where exactly we have to identify where is the field of view, like where I have put the camera. So from there, what will be I am going to capture, what it should be captured, I have to identify them from there itself. Okay, that
those
also
points are determined upfront. Those points are determined, or you keep on changing those points to ensure everything is captured?
No. This is the one procedure will follow. Okay. So and if something, for example, how the laser scanners it will looks like. So it will captures the 360-degree views. Okay. How my for example, I can stand in the particular area. I will rotate my body 360-degree. I will rotate my head 360-degree. Okay. So I can see the visualization, what is going to be captured. In the same way, the laser scanner is going to capture. How I can see in the human eyes, the same way it will going to capture everything. If I something see in my human eyes on the particular area, the lasers can also see the particular things.
Okay. Okay. Thank you.
So I hope I have answered your question.
Yes. Thank you.
Okay.
Thank you, ma'am. The next question is by Professor Shashank. If he could unmute himself and ask the question. Yes, Shashank, sir, you're audible. Yeah. Shashank, sir? Okay, while that happens, I'll just read out his question. He asked what kind of, yeah, sir, are you?
Yeah, I can able to read it.
Yeah. What kind of camera was used for creating VR content for the old building that was shown? And what was the kind of software used to convert it into VR? So,
Yeah. Great question. Okay, so it's this VR content we can create it in a three forms also. Like in the 360-degree cameras, we can use it, or we can use it by DSLR also. And third one is we can use it with the uh, laser scanners. One is with the laser scanners, one is with the DSLR, one is with the 360-degree camera. Okay, so which is good and which is affordable, I will tell you. So DSLR, it is very affordable. We can go with the DSLR shots, and which is need of some setup for that. And the VR DSLR will not give the immersive. Okay, it will jump from one place to another place, but it will create a VR content. Okay, so if I want a immersive, completely immersive environment by how I can physically walk into the particular place, you can also see it in the same way. You have to go with the Matterport cameras. Okay, Matterport or a Insta 360, Theta 360, we have to go for that. So another, so the same software with the Matterport also will be there. The Theta also will use the Matterport software. And VR content creation for the DSLR, we have a multiple software is there. Multiple software like host 360 degree, design 360 degree. Okay, VR 360 degree. There are multiple. There are n number of content creation, VR content creation softwares are there. But what I have showed, that is with a Matterport, that is a very high accuracy, and it will also captures the visualization and the crowd point. That is a one advantage, and this is the most best cameras in the world. Okay, this is the imported one. Okay, so we are using it. We have two cameras of this. Okay, so and what is the software? The same software Matterport, and LiDAR also, it will capture the 360-degree images, but that much the same way how the DSLR software will work. It will jump from one place to another place. But if you want to see the cloud points in detail, so we have to capture. We have to go with the LiDAR scanners. You don't need of any cloud point. You don't need of much cloud data. So no need to go with LiDAR scanners. Only for the visualization purpose, you can go with the Matterport. So if you want to complete structured, complete cloud points data for the recreation of the building, for the recreation of the surfaces. So if you want to plan exactly what you want, so that concern is there. So you have to go with the LiDAR scanners. But visualization, we can see it. But for the visualization, for the entire thing, I will come to the conclusion that for the visualization, you go with the Matterport. If you want more cloud data, you will go with the laser scan.
yes, thank you so much. Your knowledge in this field is really wide, and I'm really grateful that you took the time to share everything with us, and in such a nice and easy. I mean, it was very easy for us to understand the way you structured your entire presentation. So,
Okay.
thank you so much, Rakshit, for your time today.
Thank you.
Yes, thank you so much.